Hello, welcome to yet another programming tutorial on the interwebs. So this time we're looking at how to make command line applications on Windows which support Unicode in a portable way. This is a seemingly easy problem on other platforms like Linux, and yet it's way different on Windows. So let's jump right in. Here I have an example program. This is an AI chatbot using some advanced machine learning algorithms. So here is how the chatbot is reading what you are saying to it, and here is it using advanced machine learning to be able to generate a reply back. So let's run this example by compiling it, and then now let's try running it. So now we can say something to the chatbot. Let's say hello, and it replies hello back. Now let's try talking to it in Chinese. And interestingly enough, it gives question marks back instead of the Chinese characters that we expected. And so I guess the chatbot doesn't understand Chinese. Now let's try sending some emojis to it for fun. Similarly, it doesn't seem to be able to render some of these emojis, and instead giving us some question marks back, although interestingly, it gave us the brackets perfectly fine, but not any of the Unicode characters. So this problem is something that seems to be mostly on Windows only. For example, if you are on Linux, this exact program works as is. Here I have an example terminal. So this terminal right now is SSH into a Linux server. And we see here that we have basically the exact same program. And if we compile this with G++ and try running it, I claim that it works exactly as is. So let's test that out. So let's run the echo program. Let's copy in some Chinese characters, and boom, gives us those Chinese characters back. Let's try that again, but this time with the emojis. And yeah, we get everything working perfectly fine. So this is a Windows problem, and on other platforms like Linux, there is no issue. So why is that? Well, first of all, on Linux, Linux is using UTF-8 encoding for Unicode characters. What that means is that it's encoding Unicode characters in sort of like 8-bit blocks. And so when you have a string, you have a stream of 8-bit blocks, which are chars. And so UTF-8 fits into a string perfectly fine. However, Windows is using UTF-16 for Unicode encoding. What this means is that you have essentially a stream of 16-bit blocks. And unfortunately, a string, like each element of a string, which is a character, is only 8 bits. You're not going to be able to fit 16-bit blocks into sort of 8-bit slots, if that makes sense. And so the string doesn't work out of the box for Unicode characters on Windows. Now, if you look on Stack Overflow, what people are mostly saying is essentially to, instead of using the standard strings, to use wide strings, essentially changing the STD string here to be STD wstring, which is a wide string, and you'll see you get a compiler error now, which and so everywhere you use other functions like cn, you have to now use wcn, and if you use cout, you have to use wcout, and now it should just work. So let's try to compile this again. And we can try to rerun. Let's copy some Chinese characters. And it didn't work. And the reason why that didn't work, despite everything seemingly working in theory, is that Windows, under the hood, has a sort of translation layer when it comes to stdin and stdl. And so if you want this to work, what you need to do is set that translation layer to be using UTF-16. So let me show you how to do that. Up here you gotta include some stuff, namely io.h as well as fcntl.h. This gives you access to the functions, set mode, as well as file number. So we're going to pass in the file number of stdin and set the translation mode to be OU16 text. and then we're going to do the same thing when it comes to std out. Oops. There we go. Cool. So now let's build this and run again. Let's throw Chinese characters as well as throw these emojis. Cool. Looks like everything is working now, finally. But we're not done yet, though. At this point, people on Stack Overflow, they might close this question as close this question, and mark it done, pat themselves on the back, call it a day, kind of thing. But I say we're not actually done. I don't think this solution proposed here is exactly in the best form. Namely, if you want to use like wstrings, this will only work on Windows and it won't work on Linux, because on Linux you shouldn't be using wstrings, basically, for any reason. And so if we want to use wstrings here, that means that if you have an app that you want to work on both Windows and Linux, then the Linux version will use strings everywhere, whereas the Windows version will only use wstrings everywhere. And as such, you have to basically write the same code twice. So to illustrate the point, let's say we have like a library function foo, right? And we want this function to work on both Linux and Windows. And let's say this function takes in a string path, and then it opens a wstring to read the to write from the file. So you pass in the path, and then give this variable a name, and then you start, I don't know, cd string equals, or you can just write to the file directly, hello world, right? So if you want like to have library functions like this, right, that work on both Linux and Windows, well, this solution proposed here is not going to work, right? Because on Windows you need to be using wstrings everywhere. So that means you have to change this function to be using wstring, wostring, etc. And you also have to change this string literal to be wide as well by using the L mark. And so, I mean, this is just not a great solution, right? If you want to have both Linux and Windows support, because you're going to have to write this function twice. And so next I'll show you basically how to avoid this situation. I'll show you how to make string work for Unicode characters on Windows. And the advantage of that, obviously, is now you can have the same code working on both Linux and Windows without having to write it twice. So let's get to that part. Okay, now let's take a look at how to fix this. First thing we're going to do is get rid of this because we don't need it anymore. And let me explain the basic strategy. So your input that you're getting from SDVN, that's going to come in as UTF-16. And so initially it's going to have to be a wstring. There's no helping that. However, basically, as soon as you get the input as a wstring, you are free to convert it to anything you want, right? And so as soon as we get the input, we are then going to immediately convert it to a UTF-8 narrow string. And then we're going to be able to pass that to all of our library functions, which are also compatible with Linux. So let's take a look at how that can be done. To start, let's rename this to be temp. And instead of passing temp here, we're going to convert it before printing it or doing anything else with it. So how we're going to convert that is we are going to use a function which doesn't exist yet. So we're going to say call this function, I don't know, convert from wstr or something like that. We're going to pass temp to it, and then this function is going to automatically give us the UTF-8 conversion from the UTF-16 as a narrow string, and that's the idea. And then later on in our program, we can keep on using cout as well as pass in the input here. Cool. So let's take a look at how do we get this convert from wstr function. I'm just going to copy and paste some code here because the function that I'm going to show you is a bit long. So just sit tight for that. Alright, I just got some code in, so let's take a look at how we can convert from wstrings to narrow strings. There are sort of many examples of this on Stack Overflow, so you can definitely look up other ways to do this. For example, if you're on C++ 11 to 14, there are standard library methods which makes this much more shorter. unfortunately, I'm on C++17, so that's not something I can use. Also, there's third-party libraries as well. The one I am presenting here is a Windows API solution, but there's, like I mentioned, many other alternatives. So let me just quickly walk over this code. I'm using the Windows helper wide char to multi-byte. So this, if I want to use this, I have to include the Windows header, of course, and this helps to convert from wide chars to a multi-byte string. Namely, in the parameters, we pass the code page as UTF-8. That's how it knows to convert this to UTF-8. I pass error on invalid characters for the flags. So this means that if it finds something that it can't translate from UTF-16 to UTF-8, then it just returns 0. I find this in practice to be the best one to avoid undefined behavior. But if you check the Windows docs, there are sort of other flags that you can really fine-tune the behavior of this function to make something that works for you. Cool. One quirky thing about this implementation is that I actually have to call this function twice. So the first time I call it, I'm passing in null for these parameters, and what that means, or what that tells this function, is to return the UTF-8 size. So the result out of the conversion from the result of the conversion from UTF-16 to UTF-8, the size of that result UTF-8 string isn't sort of so obvious on first glance. You actually have to walk through the conversion to be able to get that size. So that's what we're getting here. So once you have gotten that size, we're able to create a string and then sort of allocate that many bytes for it. And then now we can pass this in to the function, and now it'll write the result, and then we can return that here. Cool. So now we have a way to convert between wide strings and narrow strings. So let's take a look at what we can do from here. Actually, I forgot to mention this, but what we got now that we have converted from our UTF-16 to UTF-8 narrow string, we no longer need to have this set mode thing here because we're outputting the right UTF-8 bytes. So let's just get rid of that. We will want to still keep the STD in though, because we still want to receive the Unicode input. Okay, so now let's try building this and running as is. All right, so it's built. Let's try running this. Let's throw these emojis at it. We got some interesting but different garbage this time. So what actually happened? Well, turns out that your terminal, so right now I claim that actually we are receiving the right bytes. However, the terminal isn't just displaying them correctly. And so to prove that to you, let me run this test again, but this time output the std out to a file. And let's use the same input. And now this created the test.txt in our file. So I'm going to open this file as a UTF-8 and see what happens. Well, look at that. It was the same input. So even though that our output on the terminal wasn't correct, we know that the bytes being fed to std out were correct. It was just not displayed properly. So if you do want it to be displayed properly in your terminal, what you got to do is you got to change the code page. If you're on CMD, what you do is chcp 65001, which is the code page for UTF-8. I'm on bash, so I don't actually have that command. What I can do instead is chcp.com 65001, which does exactly the same thing. This changes the code page. Now if we, whoops, that's not what I want to do. Now if we run this again, and we use the same input, voila, it works. So finally, it was a long path to get here, but we got Unicode input and output working on Windows without necessarily having to pass wide string everywhere. So what I mean by that is that now in here we're seeing that we're using cout, right? So if we had other library functions like the one before, right, like the void through std string, we can keep using that now. So this function which works on, whoops, I meant to have foo outside here. So this function which works on both Linux and Windows, we will be able to keep on using it on Windows, because now that we converted our input from a wide string to a standard string, we'll be able to just call through with our input. And now we don't have to worry about keeping two versions of the wide string version and the standard string version. There is one remaining issue here, is that if, for example, within this library function itself, right, you want to be able to call cin something. So this function won't be portable because this is going to have to use wstring. Remember that like everything else can be using normal strings except for cin. We're still using wstring in this solution. So this is not going to be portable. But there is one way to fix it. So let me show you that right now. What you're going to do is get some help from polymorphism. So you're going to define a class input getter. And so this is going to be a pure virtual class. So we're going to have a virtual getLine function. This is going to take in a reference to a string line, and it's going to modify that string with the UTF-8 input. So, oh, whoops, because this is a pure virtual function, we're going to mark that as 0, not give it implementation. So on Linux, you're going to define a narrow input getter, which inherits from this class. And so you're going to override the getLine function. Let me just write some pseudocode to illustrate the point. And then in here, basically, we're going to call std getLine on cin on that line, modify it directly, and then return some, I don't know, success or fail signal. So that's going to be how it's going to be on Linux. On Windows, on the other hand, we're going to have a wide input getter. This is going to inherit also from input getter. The difference is the getLine, when we override it, this one's going to be a bit more complicated, but nothing too bad. So we're first going to declare a wide string, call it temp, and then we are going to call std getLine wide cin on this temp, and then doing exactly the same thing that we did before, we will convert this into a UTF-8 normal string, put that into line so the caller can get it, and then similarly we're going to return success or fail stuff. So I'll leave those details up to you how you want to do this, but this is a general idea. So what this means is that with these three classes, we can redefine foo. In particular, we will pass to foo a reference to the input getter, or if you want, you can use unique pointers and all that stuff. And then instead of doing wcin or cin something directly, we'll just use the getter.getLine to wrap around this, get the line, and then down here you can use line to do whatever you want. Yeah, so to show how you can call this function on Linux, what you're going to do is you're just going to call foo with so you're going to make an input getter, possibly a pointer to it, getter, so with that we can use polymorphism, and we're going to create a new narrow input getter. This is on Linux, and then we're just going to call getter and then blah. That's how we're going to call foo on Linux. And then on Windows, we're going to basically do the same thing, except now we're going to instantiate the wide input getter. So now your foo function doesn't have to change. The only thing is how you sort of do the dependency injection stuff. So in your main function, for example, on Linux, you'll instantiate a wide input getter, then pass that to all your functions. In your main function on Windows, you'll instantiate the wide input getter, pass that to all your functions, but the functions itself don't have to change. So cool. It's been a long journey, but this has been how you get Unicode support portably on Windows. Hope you learned something from this video. Leave a like and subscribe, and I'll see you for the next one. Thanks for joining.